So we're going to be working on applications of quadratic equations, so that's why we did practice solving equations for your warm-up today. So I have, I believe it's 4 examples, yep, 4, of different kinds of word problems that they can ask involving quadratics. It's not the only kind, but these are the ones that we most generally see. So we're going to work through these. I mean, you guys have been doing word problems for a long time. A lot of times with quadratics, they give you the equations already. There are a few instances where they don't. So like this first one here, we have the area of a rectangular lawn is 14 meters long and 10 meters wide. A strip of uniform width is mowed around the outside of the lawn. How wide is the strip when the area of the unmowed portion of the lawn is 12 meters? So right here in the middle, this represents the unmowed portion. So that area is 12, that little inside rectangle there. So then going along the outside, this side here is your 14 meters. This side here is your 10 meters. They want to know how long this strip is that they mowed around that lawn there. So what would be the length of this side of the rectangle here? Does anybody think they might know? Well, it has something to do with the 10. So we've got this is 10. But what did they take out? How many x's? 2 of them, because they cut one strip on one side, one strip on the other side. So they took out 2 little strips. So this rectangle is 10 minus those 2 strips. So 10 minus 2x is what that length is going to be. So on the other one, our longer side, similar to our other one, it's the 14 meters, but with this strip taken out and that strip taken out. So that would be 14 minus 2x. So 10 minus 2x is one side, 14 minus 2x is the other side. So area means we multiply those 2 together. And it has to equal the area of that unmowed section there, that area of 12. Because when you take out those 2 strips, you're left with the unmowed section. So now we got to solve for x. So for this one, what we're going to want to do, our distribution here. So 10 times 14 gives us 140. 10 times negative 2x is going to give us negative 20x. And then we'll distribute our negative 2. So negative 2 times 14 will be negative 28x. Negative 2x times negative 2x is positive 4x squared. And then that still equals 12. Subtracting our 12 over 140 minus 12 would give us 128. Combining also our x's, we get a negative 48x. And then plus our 4x squared still. That didn't have anything to combine with, so that stays as 4x squared equals 0. So now at this point, we got to keep working towards solving x. So we have a few choices. We can try factoring, we can do quadratic formula, we can try completing the square. So what method do we want to use to solve? You get to pick. All right, let's go with completing the square. I love completing the square. So because your x squared term has that 4 in front of it, in order to do completing the square, we got to get rid of that. So we're going to divide everything by 4. And I'm also going to rearrange it. I'm going to put my x squared first. So 4x squared divided by 4 gives me x squared. My x would come next. 48 divided by 4 would give me a 12x. And then 128 divided by 4 gives me 32. So x squared minus 12x plus 32. To do completing the square, I'm going to move that 32 over. Put our spaces in there. So remember, to get that number that goes in the space, you're going to take half of this value here. So half of 12 is 6. And then we got to square it. So 6 squared is 36. 36 goes on those lines. So we get x minus 6 squared over there on the left side when we factor. Negative 32 plus 36 gives us a 4 over on the right side of the equal sign. So now I'll take the square root of both sides. Let's look over here. Remember, when you take the square root of both sides, you gotta do plus or minus over there. Nope, you gotta take the square root of 4. Square root of 4 turns into a 2. No, because we divided by it. It's gone. I didn't GCF it out, I divided by it. So 6 plus 2 gives me an answer of 8. 6 minus 2 gives me an answer of 4. So 8 and 4 are our two answers. So now what you always have to remember with your word problems is you have to check to see if your answers make sense. So if I go back to my rectangle over here, my side that was 10 minus 2x, if I plug 8 in for my x, that would give me 10 minus 16. Can I have a side that's negative 6? No. So that 8's not going to make sense. I can't keep the 8. That's going to get rejected. So our answer would be the 4. So the strip is 4 meters wide. You always got to go over and check, make sure your answer makes sense. A lot of times with quadratic word problems, we do end up rejecting one of them. All right, here's another kind of example of a quadratic word problem. So here we have a frog jump straight up from the ground. The quadratic function f of t equals negative 16t squared plus 12t models the frog's height above the ground after t seconds. About how long is the frog in the air for? So this one's nice because they're already given you your equation. You don't have to try to come up with one on your own. This is a negative t squared, so that means it's going to be an upside down parabola. It's going to end up looking like that. So we are looking for how long it takes for the frog, or how long is the frog in the air. So we're looking for how long this whole trip is. So we're looking for when he hits the ground again. So you're looking for that value, that other x-intercept value. Well, at this point in time, that x value we're trying to find, but our y value is a 0 because you're on your x-axis there. So you're looking basically for a height of 0. So that means we want to set that equation equal to 0 because we're looking for that when that frog hits the ground again, because that tells us how long he's been in the air for. So this quadratic function here, negative 16t squared plus 12t, it has a GCF for it. So let's practice our GCF factoring. 16 and 12, I can take a 4 out of both of those, and I'm going to make it negative because my first leading coefficient there is negative, so I'm going to take out a negative 4. They also both have a t. Negative 4t is going to be my GCF. And then in here, I'm going to get 4t minus 3. So now we'll set these both equal to 0. After we factor, we set them equal to 0 to figure out our values for t. I'm going to divide by this negative 4 because it's negative 4 times t. But 0 divided by anything is just simply going to be 0. For the other one there, we'll add the 3 over. So we have 4t equals 3, divide by that 4, and we get the decimal 0.75. So again, we have two answers. We have to kind of think through the problem to see if we can keep both answers or if we have to reject them. So t of 0, that means the frog is in the air for 0 seconds. Does that make sense? No. That would be his starting point. That's when he first starts his jump. We're not looking for when he first starts his jump. So that's going to be the one that we end up rejecting. So our answer ends up being that he's in the air for 0.75 seconds. Which makes sense. It's a frog. It's not like they can jump forever. If I got like 30 seconds there, I'd be like, not a right answer. So again, you got to make sure it makes sense. Less than a second makes sense. All right, max-min word problems. And then max-min with area down there. So max-min means you're trying to find your vertex. Remember, our parabolas, they either open upwards, in which case you have a minimum, or they open downwards, in which case you have a maximum. So with your max-min word problems, you are trying to figure out algebraically what are those max or min values, because that's what's going to answer your question. So here we have a rocket is launched upward with an initial velocity of 120 feet per second from a platform that is 40 feet high. So what that means is we've got a little platform here that's 40 feet high. And then our rocket gets launched up, and then it comes back down. So my green is my rocket's path. Goes up, and then it comes back down. So the rocket's height after it has been launched is given by this function here. Negative 16t squared plus 120t plus 40. Where s is the height in feet and t is the time in seconds. So we're dealing with feet and seconds here. Find the maximum height of the rocket and the time it takes the rocket to reach that maximum height. So if I were to finish off my picture here, this line here where the platform is, that would be your y-axis. My x-axis would be down there on the ground when the rocket eventually reaches the ground again. We're trying to find this value here, that maximum value. They want to know what is that maximum height and when does the rocket reach that maximum height. So your x is always your time. So finding your x value of that vertex there is going to answer the question of when does it reach that maximum height. And your y value is always your height. So then we got to figure out the y value in order to figure out what that maximum height is. So for these problems, we have to use our axis of symmetry formula. which is the formula that gives us that imaginary line that goes right through the middle of that parabola, which is x equals negative b over 2a. Again, it is the first part of that quadratic formula, so you can always use that to help you remember what your axis of symmetry formula is. And again, instead of x's this time, they're using the letter t's, so I'm just going to switch that back to t. So then going from our formula, b value from this equation is 120, so I got a negative 120 over 2 times the a value, which is negative 16. So I get negative 120, 2 times negative 16, negative 32. Somebody help me out, divide those. Negative 120 divided by negative 32. Hmm? 3.75. So that answers one of our questions. It takes 3.75 seconds for that rocket to reach its maximum height. So that answers that part. To actually figure out the maximum height, you're now going to take that 3.75 and you're going to plug it in for t of that equation that they gave us. So negative 16 times 3.75 squared plus 120 times 3.75 plus 40. So go ahead, type that all into your calculator just like that, using parentheses and everything. Negative 16 parentheses 3.75 squared plus the 120 times 3.75 plus 40. What do we get? $265. $265 feet. That is your maximum height. So x equals negative b over 2a tells you when. Plugging that number in tells you how high. So our last one here, max min with area. Find the maximum rectangular area that can be enclosed by 452 meters of fencing. Doesn't really give us much to go on, but talking about a rectangle, so we'll start with that. Let's draw our rectangle. It tells us it's enclosed by 452 meters of fencing. What piece of information did they just give us? 452 meters of fencing. Well, where does fencing go? Around the outside, right? What's it called when we go around the outside? Perimeter. They gave us the perimeter here. So we know what the perimeter of the rectangle is. We have to figure out the area. So I'm going to say that those sides, those lengths are x. We don't actually know the length, so I'm going to assign it a variable. Now, remembering what we know about perimeter is you add up all your sides. So 452, which is our total perimeter, minus the two sides that I just called x, so minus the 2x. That would give me these two sides together. So if I divide this in half, that's going to give me one of those two sides. So let's see here, that would be 2, 6 minus x. So that's going to be the length of the other side. 226 minus x. Now we have variables for that side. Going to allow us to multiply them together. So area equals your length times your width. So x times your 226 minus x. So I multiply that through, I get 226x minus x squared. So again, because this has a negative x squared, if I were to graph it, it would be an upside down parabola like this, because it's got that negative x squared. It always makes it go upside down. We're trying to find the maximum area. So we're trying to find the vertex there. That's the maximum height. That's going to be, well, not height. That's the maximum area for this one, because we're talking about area, not height. So in order to do that, we've got to start first with negative b over 2a. That's going to help us find the x part of that. So our b value is 226 over 2 times negative 1, which would be negative 2. What's 226 divided by 2? 113. So now if I plug 113 into my equation for x, that's going to give us what our maximum area is. Go ahead and multiply this. 226 times 113 minus 113 squared. That would be meters squared. 12,769 meters squared would be the maximum area that they could possibly find. So anytime it talks about maximum minimum, you got to be thinking about this. Negative b over 2a is always how you start for that. And then usually plugging that value in helps you answer the rest of it.